For problem 5, I want to find the exact value of sine of 15 degrees. Well, for this, we're going to use our sum and difference of angle formulas. So, if I have 15 degrees, I could rewrite that as sine of 45. Let's switch colors again. I can't pick a color today. Let's go back to pink. Sine of 45 degrees minus 30 degrees. And we have a formula it's going to be given to you on the exam, and that is that if I have sine of 45 degrees minus 30 degrees, that's equivalent to sine of 45 degrees cosine 30 degrees minus cosine 45 degrees sine 30 degrees. And then we look up these values in our unit circle because I want it to be exact. Sine of 45 degrees is square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. Cosine of 45 degrees is square root of 2 over 2. Sine of 30 degrees is 1/2. Yeah, 1/2. So that gives me square root of 6 over 4 minus square root of 2 over 4. That equals 1/4. Square root of 6 minus square root of 2. And if you didn't factor it, but like you just wrote it as like one fraction, I'd be super happy. That's all I want. Now let's try to find the exact value of cosine 5 pi over 12. When you come across this problem, the first thing you should do is rewrite, if you don't know it already, rewrite all radians on your unit circle with a denominator of 12. And you'll see that I have on that unit circle, I have cosine of 3 pi over 12 plus 2 pi over 12. Well, 3 pi over 12 is pi over 4. And 2 pi over 12 is pi over 6. So I'm going to have cosine pi over, let's do pi over 6, cosine pi over 4, the order doesn't matter, minus sine pi over 6, sine pi over 4 is going to give us the exact answer. Cosine of pi over 6 is the square root of 3 over 2. Cosine of pi over 4 is the square root of 2 over 2. Did I program 2 problems with the exact answer? Yes. Minus sine of pi over 6, which is 1/2, over times sine of pi over 4, which is the square root of 2 over 2, which again gives us the square root of 6 minus the square root of 2 over 4. Can I just get like bonus points for creativity, please? Oh my gosh. Next, we want to find the exact value for sine inverse of sine negative 2/5. Well, remember this is just composition. Those two signs cancel each other out. Okay, that's going to give us negative 2/5. Final answer. Very creative, very proud, I know. For problem 8, I have to solve one of the following. So I solve for alpha. So I have cosine squared alpha plus sine alpha equals 1. The first thing I want to do is replace this cosine squared alpha. I'm going to rewrite that as 1 minus sine squared alpha plus sine of alpha equals 1. Subtract 1 from both sides. I get negative sine squared alpha plus sine alpha equals 0. And then I factor out a factor of sine. I then use the zero factor property, set each of these equal to 0. I have sine squared, sorry, that shouldn't be a square anymore. sine of alpha equals 0. So where does theta equal 0? Well, that's when when alpha is 0 or pi, right? That's where we've got sine equal to 0. So those are our first two answers. Next, I have to, sorry, it's hard to jump around. Next, I have to set negative sine of alpha plus 1 equals 0. That gives me sine of alpha equals 1. Well, where is sine of alpha equal to a positive 1? That's when alpha is pi over 2. So those are our three possible answers for this problem. Next, I have three trig identities. I'm going to go ahead and stop this video and do a final one just for problem 9.